Here we go. We're gonna basically break these denominators down into 3 times x. Isn't that what 3x means? 3 times x? Yes? Okay. Plus 1 over 6 times x minus 1 over, what if I factored x squared into 2 factors? What would it be? What times what? X times x. So this has a 3 times x, 6 times x, x times x. Well, they all need 2 x's. So this needs a times x, times x, times x, times x. And we're almost there. This one's x times x. This one's 6 times x times x. So what does this fraction need? It needs a 6. So I'm going to multiply 6 on top, 6 on bottom. Now we're almost there. 2 of our 3 fractions have 6x squared in the denominator, but there's 1 left. What are you going to do? I liked when you said multiply better than add, right? Multiply the first fraction by 2, all right? So we're going to do times 2 times 2. I think we're ready to go because the first fraction is now, what's 2 times 1 times x? 2x over, what's all this come out to be? 6x squared plus, what's 1 times x? X over 6x squared minus, what's 6 times 1? 6 over 6x squared. Do we have a common denominator? Say yes. Good. What's 2x plus x? 3x minus 6 over 6x squared. I put the pen down, but that could actually reduce just a little bit. Do 3 and 6 have a common factor? Do 3 and 6 have a common factor? That's a question from elementary school. Do 3 and 6 have a common factor? What is it? 3 is their common factor, leaving behind x minus 2 when you factor out the 3. So if you said 2, I get what you're saying. The 2 is left over from the 6. On the bottom, you have 6x squared. So when I said this reduces a little bit, what does 3 over 6 reduce to? 1/2. So a good final answer here would be x minus 2 over 2x squared, because this reduces to 1/2. Now we can put the pen down and be done with the problem.